everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the Introduction to Electrical Circuits question bank. So here we have total 20 questions. First question is it possible to connect directly two current sources 5 amps and 3 amps in series? And similarly, can we connect directly two voltage sources 2 volts and 6 volts in parallel? So justify your answer. First one here, so two current sources. This is 5 amperes. Current source symbol, this is the current source and this one is the current source. So this is 5 amps and this is 3 amps. They are connected in series. So we know that in series case, same current flows to the each element. So here two different currents in series circuit. It is not possible. Is it possible to connect directly two current sources 5 amps and 3 amps in series? So either it is 3 amps or it should be in 5 amps. So the current should be same in case of series circuit. It is not possible. And same way here in parallel case, same voltage. This is series connection property. Series connection, that current source value must be same in case of series current sources connection. So next, this is the two parallel circuits. Can we connect directly two voltage sources 2 volts and 6 volts. This voltage must be same voltage developed across the each element in case of parallel connection. So it is also not possible. And this one is also not. So same voltage. If it is 2 volts, it must be 2 volts. If it is 5 amps, it must be 5 amps. So the same voltage developed across the each element, and in case of parallel connection, same current flows to the each element in case of series connection. So that is most important. It is not possible, and this one is also not possible. Only series connection properties and parallel connection properties, you need to keep it in mind. So now second question, state and explain Kirchhoff laws, Kirchhoff voltage law and Ohm's law, Kirchhoff current law and Kirchhoff voltage law and Ohm's law with suitable examples. So first, Kirchhoff current law. What are the Kirchhoff laws? Kirchhoff current law, KVL, and next KCL, and this one is the Ohm's law. So now here, Kirchhoff voltage law. First, I will explain Kirchhoff voltage law. Kirchhoff voltage law. This one I am explaining. First one. So first, Kirchhoff voltage law means in mathematical format, algebraic sum of voltages in a loop equals to 0. This is suppose. This is V1 supply voltage and VR1, this is R1 voltage, and R2 voltage VR2 and R3 voltage VR3. Now algebraic sum of total voltages in a loop equals to 0. Here K equals to 1 to N. So Vk here. K is the kth element voltage. Now here V1 plus VR1 plus and VR2 plus and VR3. Here current is flowing. It is a rising voltage. So this is plus and these are drop voltage and minus. Now here this is minus, this one is minus and this one is a minus. Now V1 is equal to VR1 plus VR2 plus VR3. KVL. Algebraic sum of total voltages in a loop equals to 0. And next, in case of Kirchhoff current law, so this is the 1 element, 2 element, 3 element, 4 elements and 5 elements connected to one part. Algebraic sum of total voltages in a loop equals to 0. Here algebraic sum of currents at a node equals to 0. Entering, leaving, entering and leaving. Now here sum of entering currents equals sum of leaving currents, or algebraic sum of entering currents, algebraic sum of currents at a node equals to 0. This is the node. K equals to 1 to N. So Ik, kth element current, And here what are the entering current? This is the I1, I2, I3, I4 and I5. What are the entering currents and what are the leaving currents? I1, I2 and I4 are I1 plus I2 plus I4 are entering currents equals to I3 plus I5 are leaving currents. Sum of entering currents equals to sum of leaving currents, or algebraic sum of currents at a node equals to 0. This is KVL and this one is the KCL. And next, what about voltage Ohm's law? Here Ohm's law means V is directly proportional to the I. Voltage across any element. Suppose this is the one resistor, voltage V, and that resistance is R and current flowing through this one is I. Now voltage across any element is directly proportional to the current. V is directly proportional to the current and V is equal to IR. Here R is a proportionality constant and this R equals to rho L by A. R is the specific resistivity and L is the length of the material and A is the cross-sectional area of this conductor. This is regarding Kirchhoff current law, voltage law and Ohm's law. Now next, third question. Same question here repeated. The Kirchhoff voltage law and current law with neat diagram. Same diagram, these two diagrams. So in the previous diagram, this one and this one with the examples with a neat diagram. Same question. Next, Kirchhoff voltage law and Kirchhoff current law mention. So these up to this one it is okay. Kirchhoff voltage state, algebraic sum of total voltages in a loop equals 0, algebraic sum of currents at a node equals 0, or sum of entering currents equals sum of leaving currents, that is Kirchhoff current law, and sum of rising voltages equals to sum of EMFs, that is Kirchhoff voltage law. Now make a short-term notes on practical sources and ideal sources. Here what are the ideal sources? Ideal sources, ideal voltage source and ideal current source, practical voltage source and practical current source. So suppose this one is the voltage source plus 1 and plus and minus. This is the ideal voltage source and this one is the ideal current source. Now the difference between ideal voltage source and ideal current source. Ideal voltage source, this is a practical voltage source having some internal resistance R internal. In ideal practical voltage source having some internal resistance, this R internal is equal to 0 in case of ideal voltage source. And in this case, practical this is, don't use this. Here this is the practical current source R internal, so that equals to it is having some internal resistance connected in series. So this R internal here is the infinity. So ideal voltage source, practical voltage source, ideal current source and practical current source. Now this, if you draw the graph between, if you connect one load here, so no matter this voltage value is constant no matter how much current flowing through the load. So now here this voltage value is same, so this value is constant. Here current value is constant, so here voltage and this current. So this current load independent of load voltage, but here this value is dropped because of this resistance. There may be a drop. Okay, na? The graph should be, the characteristics must be like this. This one is also same, it is not same. So this is V and I, load voltage and load current. Now next, fifth question, introduction to the next. Estimate the equivalent capacitance, series and parallel connection of capacitor elements. So now here series capacitor C1, C2 and C3. C1, C2 and C3 are connected in series and the whole circuit is connected across the supply voltage. In this case, so the equivalent capacitance C equivalent equals to the C equivalent equals to 1 by C equivalent equals to 1 by, this is series connection, 1 by C1 plus 1 by C2 plus 1 by C3. If it is a parallel, so in case of parallel connection, so now here this is the parallel capacitors and this is the supply voltage V. C1, C2 and C3. So this C equivalent equals to C1 plus C2 plus C3. If n number of capacitors are connected in parallel, so they are up to Cn, and here if n number of capacitors are connected here, 1 by Cn. Now next, list out the expressions for star to delta and delta to star transformation technique. So this is the star and this one is a delta connection. Let me change the color over here. R1, R2 and R3, RA, RB and RC. Now here RA equals from star to delta. So this RA equals to this RA equals to, I am drawing here. This is R1, R2 and R3. Now here RA equals to R1 plus R2 plus R1, R2 divided by R3. So R1 plus R2 divided by R3. Next RB equals to R3 plus R1 plus R1, R3 divided by R2. This one. And next here RC equals to R2 plus R3 plus R2, R3 divided by R1. So now these are the star terms from star to delta. Now delta to star means this one. RA, RB and RC. Now here R1 equals to RA, RB divided by RA plus RB plus RC. Next RB equals to, this is R1 equals, sorry, and R2 equals to this is R2, sorry, this is R2, this is, if you take this one R2 and this one is R3. R2 equals to RA, RC divided by RA plus RB plus RC. Next R3 equals to RB, RC divided by RA plus RB plus RC. These are the expressions for star to delta and delta to star. Now here next question. Describe the method used to determine loop currents for multiple loops network with a suitable examples. So this is mesh analysis method. Mesh. So using mesh analysis, you can determine the mesh currents, that means loop currents. So first method is here. So first take one example, this one and this one. These are the currents. So 15 volts, 10 ohms, 100 ohms, 150 ohms, 200 ohms, 50 ohms, 82 ohms and 150 220 ohms. Now here this is a 80 to 47 ohms. Now let me change the color over here, red color. So now here to determine the mesh currents. So first possible number of loops are 1, 2 and 3 in the mesh analysis, and mesh currents I1, I2 and I3 in clockwise direction. Now here I1, I2 and I3 are in clockwise direction. First determine possible number of meshes. First possible number of meshes 3 and mesh currents I1, I2 and I3 in clockwise direction. And next, apply KVL. Apply KVL in each mesh. So 15 plus 10 I1 plus 100 I1 minus I2. This is equation number 1. And next, apply KVL in each mesh. So next 150 into I2 plus 47 into I2 minus I3 plus next 100 into I2 minus I1 equals to 0. Now next third mesh equation, 47 into I3 minus I2 plus 82 into I3 plus 220 into I3 equals to 0. If you solve these equations 1, 2 and 3, so you will get I1, I2 and I3. So describe the method to determine mesh loop currents for multiple loops network with a suitable examples. So first take one circuit, in that determine possible number of meshes and assume the mesh currents I1, I2 and I3 in clockwise direction. Apply KVL in each mesh. So mesh 1 equation, mesh 2 equation, mesh 3 equation, and solve that equations. You will get the mesh equations, that means loop currents equation for multiple loop networks. Next, summarize the procedure to calculate the node voltages using nodal analysis. Same thing here. This is the circuit, 15 volts, and this one is I am taking here 10 volts, 10, 15, 20, 30 and 5 here. So first step 1, determine possible number of junctions here. Possible number of junctions, step 1. So this is nodal analysis method. So determine possible number of node voltages. Let me change the color over here. So possible number of junctions here, junction 1 and junction 2. This is the ground junction, junction 3. So possible number of junctions here, 3. And next, first junction 1, next here, select one junction as a reference junction, then junction voltage is 0. First junction voltage is V1, V2 and V3. V3 value is 0. Second one, assign the junction voltages V1, V2, V2 and V3, and select one junction voltage as a reference junction. That reference junction voltage is 0. And third, apply KCL at remaining node junctions. Apply KCL. So now here, if you apply KCL at node 1, so now V1 minus 15 by 10 plus V1 minus V3 by 15 plus V1 minus V2 divided by 20 is equal to 0, equation number 1. Next, V2 minus V1 by 20 plus V2 minus V2 minus V3 divided by 30 plus V2 minus 10 by 5. This is equation number 2. Here in this V3 value is 0. This is 0. So now if you solve these two equations, you will get V1 and V2. These two are node voltages. In this way, we can determine the node voltages using nodal analysis method. Now here, determine the peak and peak to peak value, average value, RMS value, peak factor and form factor. So for sine wave. So now here, this is the sine wave. Omega t, and this is V of t. This is the maximum value, V maximum, and this is negative V maximum. negative means pi. This is the pi by 2 and this is the 3 pi by 2 and this is 0 and this is 2 pi. Now here peak value is V maximum. This one. This is the peak value and this one is the peak value. This one. Maximum value of alternating quantity is known as the peak value or amplitude, and next peak to peak value means this distance up to this distance to Vm plus Vm, that is peak to peak value. Average value means here this is the symmetrical waveform, so area under the curve divided by total time period is known as the average value. Total area divided by total time period, but it is a symmetrical means take half cycle. So now here up to pi only, so 0 to pi it is a sine wave means, so Vm sine omega t up to half cycle only you consider. And for RMS value, root mean square means here that equals 1 by 2 pi square root of square root inside this one, square root of 0 to pi, 0 to 2 pi only up to full cycle. I am considering Vm sine omega t whole square dt. So this is the RMS value. So now here this is 2V, if you do this, this is 2 Vm by pi and this one is the Vm by root 2. This one. And next here sine wave form peak factor means Vrms divided by V maximum value. This one, and form factor equals to Vrms divided by V average value. So this value is 1.11 and this value is 1 by V maximum divided by Vrms. So this value is root 2. Next, derive the expression for average and RMS value of sine waves. So this question, this problem I derived in the previous lecture. So that lecture name is average value, RMS value, form factor and peak factor. So in that you can find this derivation for average value and RMS value. So now for sine wave, for half wave rectifier output, full wave rectifier output, triangular waveform, trapezoidal waveform, square waveform. So in that lecture you can find this sine wave. First problem only in that. Now next. Explain the concept of reactance, impedance, susceptance, admittance, rectangular form and polar form. So now here first impedance equals Z equals to R plus JX. So this is the impedance. That impedance triangle I am drawing here. This is the Z, R and X and this is the theta. So this is the impedance Z equals to R plus JX. Z equals to R square plus X square. This is the impedance formula. Impedance is Z and reactance is X. X we know that is R resistance which opposes the flow of current, and impedance is also known as which opposes the flow of alternating current. Now here this is a reactance. Reactance may be either capacitive reactance or inductive reactance. Inductive reactance is 2 pi FL and capacitive reactance is 2 pi FC. What about susceptance, admittance? Admittance is here reciprocal of impedance Z equals Y, that is represented as Y, and units are mohs. Impedance units are ohms, reactance and resistance units are also ohms. Now here Y equals to G plus JB. So if you draw the admittance triangle here, Y, G and B, this is the theta. So now here B is the susceptance here, this one, and admittance. So admittance is Y and G is the conductance here. So now here, what about rectangular form and polar form? Rectangular form is for addition and subtraction of two alternating quantities, and polar form is used for multiplication and division for two alternating quantities, multiplication and division. So now here a polar form here. So r comma theta is polar form and x plus jy is the rectangular form. If you draw the graph between this is a x and this one is a y and this is theta and this one is r. So this is theta. This r equals to square root of x square plus y square and this theta equals to tan inverse y by x and this x equals to r cos theta and y equals to r sin theta. So these are the formulas. So this one also I explained in the previous lecture. Estimate the equivalent resistance of series parallel connections of resistor elements to 3 resistors are connected in 3 resistors R1, R2 and R3. So the equivalent resistance equals to R1 plus R2 plus R3. 3 resistors are connected in parallel. 3 resistors are connected in parallel. 3 resistors are connected in parallel. So R1, R2 and R3. 3 resistors are connected in parallel. So for that case 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now here 13th question. Derive the equivalent resistance equations when they are connected in series and parallel. So this I explained in the series parallel connection. So that if 2 resistors are connected in series means R equivalent equals to R1 plus R2 plus R3 and 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. This derivation I explained in the previous lecture. So just go through that lecture, this one for this. Next, derive the expression for equivalent resistance while transforming from star to delta and delta to star. This question also I derived star to delta transformation technique. So this you just go through that lecture, this one. So star to delta and delta to star, this one. Next, derive the equivalent inductance. So equivalent inductance, so this one is also I explained in the previous lecture, series parallel connection for resistors, inductors and capacitors. So this is the L inductance, L1, L2 and L3. So this is L1, L2 and L3. 3 inductors are connected in series. So L equivalent equals to L1 plus L2 plus L3. Equivalent inductance equals sum of the individual inductances if 3 inductance are connected in parallel. So for that case L1, L2 and L3. So 1 by L equivalent equals to 1 by L1 plus 1 by L2 plus 1 by L3. So reciprocal of equivalent inductance equals to sum of the reciprocal of individual inductances. This derivation also we derived in the previous lecture. So just go through. Next 16th question. This is important. Why it is not possible to have electrolysis by AC? So it is only for DC only. So now here this is 2 electrodes. So this is minus and this one is a plus. There is a battery. So minus and plus. So at this there is a cathode and this is a anode. So now decomposition of this caution of the cathode and anode. So onion of cathode. So there is a it is only possible with the help of polarity of electrodes. Polarity of electrodes enter the same current, same that must be same current, that polarity must be same throughout the process. That is known as electrolysis. So now heat is not in case of AC it is changing, it is always changing. So now it is not applicable for AC. Now here, so mention the process of sine voltage waveform for generation. So I explained DC generator working principle. In between two opposite poles, north pole and south pole, one single turn conductor is placed. So rotating conductor placed in a stationary magnetic field according to the Faraday's law of electromagnetic induction, and induced EMF will be developed in the armature conductor. So that induced EMF is the sine wave for particular sine wave. And also list the expression for average value, RMS value for periodic waveforms. So for periodic waveforms means that is symmetrical waveform. So now here this one for periodical waveforms, so 1 by t 0 to t Vm this is the f of t dt. This is for average value, and if it is symmetrical waveform 0 to t by 2 f of t dt. So this is for symmetrical waveform, this is for the asymmetrical waveform. T is the time period here, but here t 0 to t f of t whole square dt, this is the RMS value for symmetrical and asymmetrical waveform. Next, derive the equivalent capacitance when they are connected in series and parallel. So for series case, this one 1 by C1 plus 1 by C2 plus 1 by C3, and for parallel case C equivalent equals C1 plus C2 plus C3. So this also we derived in the previous lecture, series and parallel connection. Next, mention the difference between instantaneous peak value RMS quantities and give some examples when it is appropriated to use this one. So if it is a sine wave, so sine wave instantaneous value means this is a, suppose this is 5 volts and this one is a 5 minus 5 volts, this is 0. So the value at which at instant at 90 degrees this value is 5 volts. So that is instantaneous value. At 0 this one, at 180 this value instantaneous value is 0, and peak value is here 5 volts, and RMS value quantities, this is root mean squared 1 by t 0 to t and f of t square dt. This is the RMS value. Now here 20 question. So star to delta and delta to star connection, RAB, RBC are connected in delta. So this one A, B, C, RAB, RBC and RCA. Star connection, this one R1, R2 and R3. Here R1 equals to RAB, RCA divided by RAB plus RBC plus RCA, and R2 equals to RAB and RBC divided by RAB plus RBC plus RCA, and R3 equals to RCA and RBC divided by RAB plus RBC plus RCA. So now total question 20 questions we discussed. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you.
Like, share and subscribe. Hit the bell icon for more updates.